Now we're looking at length and area problems in the context of graphs, so on coordinate axes. The first question here says find the distance between -7, 8 and 5, 3. Whenever we need to find the distance between 2 points, we're using Pythagoras. So we've got the point -7, 8, which I will say is over here, -7, 8. And we've got the point 5, 3. Let's say that's over here. And let's say we've got a straight line between them, and we're trying to find the length of that line. What is the distance between these 2 points? So we can look at our x's. How far do we go along the x's? And how far do we go on the y's? So for the x's, we're going from -7 to 5. So from -7 to 5, or 7 to 0, and then 5, that's a distance of 12. And on the y's, we've gone from 8 to 3. That's a distance of 5. So what is the overall distance? We need to find the length of the straight line, and that's Pythagoras. A squared plus b squared equals c squared. So we're at a squared plus b squared equals c squared. 12 squared plus 5 squared equal this hypotenuse squared. So 12 squared plus 5 squared equals c squared. And we can just use a calculator. So we want the square root of 12 squared plus 5 squared. And that will be 13. So c must be 13. So the distance is 13 units. One for you to try. Give it a go. So we've got -1, 4, -1, 4, and 7, -2. So how far on the x? -1 to 7 is 8. 4 to -2 is 6. So we want to find the hypotenuse. And, well, it's a 3, 4, 5 triangle, doubled, so it must be 10. So 6 squared plus 8 squared equals x squared. That's 100 equals x squared. X must be 10. So it's 10 units. The distance between -2y and 1, 7 is 3 root 5. Find the 2 possible values of y. So this time we are given the length, so we know the hypotenuse, and we're going to have to use Pythagoras to work out a missing coordinate. So the same thing, we've got -2y and 1, 7. We're going to have a Pythagoras question, but this time the unknown is different. So the hypotenuse we know is 3 root 5. The change in the x's, the distance between the 2 points, for the x's is, well, from -2 to 1 is 3. And the change in the y's, we've got 7 on y. How do we find the distance? We take them away. So the same as if we said we did 1 take away -2, which was 3. We can just do 7 take away y for the distance between these 2 points. It doesn't matter if we do y minus 7. That's the same. It'll be the same distance. And the reason there are two possible answers, the 2 possible answers, is because the triangle could also be up here and still have the same distance. So y take away 7 or 7 take away y. Either way, we're going to get 2 different answers. Pythagoras is a squared plus b squared equals c squared. So now we've got 3 squared plus 7 minus y, or y minus 7 squared, equals 3 root 5 squared. We just need to solve this equation now. Change 3 squared into 9. I've got 7 minus y. I'll just write it out first. 7 minus y times 7 minus y equals 3 root 5 squared. So 3 root 5 squared is 45. So it equals 45. And then I'll expand the brackets. So I've got 9 plus 49 minus 7y minus another 7y plus y squared equals 45. Let's make it equal to 0. Get all the y's. Get everything over to the left side. So I've got y squared. I've got minus 14 y's. And then I've got 9 and 49. Take away 45. Which is, so 49 take away 45 is 4. 9 and 4 make 13. Then I can just factorize this. It's 13 and 1. So y minus 13. Y minus 1 equals 0. So y could be 13 or y could be 1. And you can check your answer. If you change y to 13 or 1, you can see you're going to get a 6 here. So 7 take away 1 is 6, and 7 take away 13 is negative 6. And then you'll have 3 squared. Let's do the square root of 3 squared plus either 6 or negative 6. If I do negative 6, I'm going to put it inside a bracket. And you get 3 root 5. Okay, one for you to try. Pause the video and give it a go. The distance between x, 6, and negative 2, 3 is root 34. Find the two possible values of x. So we've got x, 6, and negative 2, 3. We know the hypotenuse is root 34. Oh dear. The distance between the y's, 6 to 3, is 3. The distance between the x's, so just take them away. So either x take away negative 2, which is x plus 2, or negative 2 take away x. Either way around, I'll put x plus 2. That seems nicer. So then we just write out a squared plus b squared equals c squared. So 3 squared plus x plus 2 squared equals square root 34 squared. That'd be 9. The expanded bracket will be x squared plus 2x, which is 4x plus 4. And that equals 34. Square root and squaring are opposites. Make it equal to 0. So x squared plus 4x. And I've got 9 and 4, which is 13. Take away 34, which is 21. Or minus 21 even. So we've got factorizing again. What multiplies to make 21 and adds to make, or negative 21 and adds to make a 4. It's plus 7 and negative 3. So x can be negative 7, or x could also be 3. L1 has the equation y equals x plus 1. L2 has the equation y equals negative 5x plus 16. They intersect at point A. Part A, find the coordinates of A. So they intersect where they are equal to each other. The answer to the simultaneous equations, I can just write them equal to each other. They're both y equals at the moment. So x plus 1 must equal negative 5x plus 16 plus 5x to both sides. Take away 1 from both sides. So x is 15 over 6, or dividing by 3, 5 over 2. And y equals x plus 1. So 5 over 2 plus 1, 7 over 2. So they intersect at 5 over 2, 7 over 2. L1 crosses the y-axis at B. L2 crosses the y-axis at C. Find the area of triangle ABC. So let's sketch what we've got here. So we have two graphs, L1, which is y equals x plus 1. So it crosses at 1. That's what L1 looks like. L2 has got a gradient of -5 and a y-intercept of 16. So it comes down very sharply, like so. And we know where they intersect. That was 5 over 2, 7 over 2. L1 crosses at B. So this is B, this is C, and this is A. And we want the area of that triangle. So it's this triangle here. So to find the area of a triangle, we can do half times base times height. And what we've really got to do is flip it around. So look at it from a different perspective. I will see if I can just rotate this. So look at it from this perspective. You can see the base between 1 and 16, and the height will be 5 over 2, the x coordinate. Flip that back. So we can say its area is half times the base times the height. So if we say the base is 1 to 16, which is 15, and the height is 5 over 2. So we've got half times 15 times 5 over 2. 5 15s are 75, 2 2s are 4. So it's 75 over 4. And I'll just write units squared. Okay, one for you to try. Pause the video and give it a go. So 2 lines, find the intersection. The intersection is the answer to the simultaneous equations. So we can say where 3x minus 2 equals -2x plus 8 plus 2x to both sides plus 2 to both sides and divide by 5. So x is 2. When x is 2, 3 2s are 6, take away 2 is 4. Or we could say -2 2s is -4 plus 8 is 4. The intersections at 2, 4. And again, a nice sketch of this. So L1 crosses the y-axis at Q. So that's got a equation of 3x minus 2. So that is a line like this. That's L1. L2 is -2x plus 8. And we know the intersection is at 2, 4. So find the area of PQR. Again, that's this triangle. So we're going to say that the base is from -2 to 8. That will be 10. And the height is 2. So the area is half times base times height. Half times 10 times 2. That will be 10. And we measure area in squares. L1 has the equation negative 2x minus 2y plus 1 equals 0. L2 has the equation 3x plus 2y minus 21 equals 0. They intersect at point P. Find the coordinates of P. Now this one's much better set up to just be typed into the calculator. So we can put them in the calculator if they're in the form something x plus something y equals something. So something x plus something y equals something. So I'll type these in the calculator and I'll find the coordinates of the intersection. So menu, equation or function, simultaneous equation with two unknowns. So we've got 2x minus 2y equals negative 1. And we have 3x plus 2y equals 21. So we've got x is 4, y is 9 over 2. L1 crosses the x-axis at Q. L2 crosses the x-axis at R. Find the area of PQR. So they cross x, they cross the x-axis when y equals 0. So for L1, when y equals 0, we'll have 2x plus 1 equals 0. 2x equals negative 1. X equals minus a half. And for L2, when y equals 0, we've got 3x minus 21 equals 0. So 3x is equal to 21. X is at 7. So let's have a sketch of what's going on. So we have L1 is crossing at minus a half. And they're intersecting at 4, 9 over 2. And L2 is crossing at 7. And they're crossing at, again, at 4, 9 over 2. So we've got 4 and 9 over 2, 4.5. Here, we've got minus a half. And we've got 7. So we need to find the area of triangle PQR. So this triangle here. So it's got a height. That's the y coordinate. That's 9 over 2. And it's got a base from negative a half to 7 is, well, 7.5. 15 over 2, 7.5. So the area is half times the base times the height. Half times the base times the height is 135 over 8. So I'll put 135 over 8. And we measure area in squares, so I'll put units squared. And one for you to try. So L1 has got the equation 2y equals 3x. L2 has the equation y equals negative 2x plus 7. So either put them in the calculator or solve them by substituting one into the other one. I'll substitute y in. So I'm going to substitute negative 2x plus 7 in for y in the first equation. That's 2 lots of negative 2x plus 7 equals 3x. So negative 4x plus 14 equals 3x plus 4x to both sides. Divide by 7. X is 2. Y equals negative 2x plus 7. Negative 2 2's, negative 4 plus 7 is 3. So they intersect at they intersect at 2, 3. L1 crosses the x-axis at B. So when y equals 0, L1, when y equals 0, or x equals 0 as well, 0 equals 3x for L1. So that is B. B is 0, 0. L2 crosses the x-axis at C. So when y equals 0, 0 equals negative 2x plus 7. So 2x is 7. X is 7 over 2. So C is 7 over 2, 0. That's C. So we've got our 3 points, A, B, and C. So on a graph, we've got 0, 0, 2, 3, and 7 over 2, 0. This is our triangle. ABC, we need the area. So it's got a base of 7 over 2. It's got a height. So this is 2, 3. The y coordinate's 3, so the height is 3. The area is half times the base times the height. So that is 7 3s are 21, 2 2s are 4, so 21 over 4 units squared.